Okay, so constraints. Constraints are very handy because they allow you to do things in different hierarchies. Okay, so sometimes, if I just make a quick, well, just about anything here, cylinder, cone, there we go. Okay, so I got a cone here. If I parent the cone to this ball, it follows the ball, and it's in the hierarchy. But it's sometimes you're going to want things to be in a different hierarchy than the one that you can parent them to. So you use constraints. So in the animation menu set, you go to we have the constraints tab, and let me just tear that off for convenience. Okay, so the rule of thumb is you always select the constrained item first. Okay, so the target item first, and then the object to be moved second. And you want to place your pivot points very carefully. Look where my pivot point is on this cone, look where it is on the ball, and then we'll see what happens. All right, so I'm just going to do a point constraint. And, oops, let's Z back here. And it's not happy Zing back. Okay, so we're going to do a point constraint, and I'm going to turn maintain offset to off. There we go. All right, so now when I grab the red cone and move it around, the ball, the center of the ball, is attached exactly at the at its pivot point to the tip of the red cone. Okay, and so that way I can have things in different hierarchy, and this is very important when you get into rigging. Okay, one of my favorite features is that maintain offset. So if we just Z back a few times, and I do the maintain offset now, at this point, as I move it, it maintains that distance initially. Now the thing is, note, if I rotate it, it does not care. That's going to be important in a few minutes. All right, let's see. Let me turn maintain offset off. I'm going to select both the red and the blue, which is why I've bothered name them, and the red and blue cones, and then I'm going to select the ball last. I hit apply, and at this point the ball stays 50% between the two cones. So as I move it, it always maintains that 50% offset. If I select the ball, okay, and you can see here in the hypergraph why this is. Let's zoom in a bit. We have the ball constraint underneath. If I select the ball constraint, because I named the cones first, red and blue, you can clearly see that the red weight value weight 0 and the blue weight 1, so it starts counting at 0, has these two values here of 1 each. If I put the value to completely to blue, so blue 1, red 0, moving around, this guy doesn't do anything. If I grab the blue, it does. All right, so this is incredibly handy, and it doesn't have to stop at 2. You could have 30, different. That'd be a little hard to manage, but it is doable. And so I really can let's see, I'm going to be on frame 1, and I will set the red's weight to 0, and key selected, and keep both the red and the blue's weights. And so then go to frame 24 here. I'll just set it to the opposite and key these guys. And so now as I hit play, it switches which one it's following. So if I also at the same time set a key on the red guy, you'll see what happens. Okay? So as that guy's moving, the ball moves accordingly. So very handy, very powerful little concept here. Okay, so that is the point constraint, and it's pretty straightforward. All right, pulling all of that off. Breaking my connections, break connections, and yeah, okay, so. All right, so now I'm back to normal here. Put that back up so we can see it. All right, so that's your basics, and note that you can do one axis at a time. You can constrain. You don't have to do all of them. So that can be also very handy. All right, so there's also the aim constraint. Let me just make a new cylinder cone for that. All right, and so if I select the ball first and the cone second, and do a aim constraint. Let's see, that is the x. So x. So aim vector is x. The up vector is y. Yeah, that's good. I hit apply. Now, as I move the ball, it controls the cone there. All right, so that's the aim constraint. Very handy. Note that it has its rotations now keyed out. Okay, so I can't manually key the rotations on this guy. All right, so I'd have to, if I needed to do a manual rotation as well, probably would have to put a group in to do it. All right, so I'm killing that guy off. Righto. The next one is the orient. All right, and I'm just gonna, I'll grab both of these guys again, the ball last, and grab, toss on the orient constraint. Notice it on the ball, it keys out the rotations again. When we're using the point constraint, it just keyed out the translations. And you do want to note that if you're using the follow attribute with the attached to path, that keys out the translates and rotates. So you need to have that on a group if you're going to animate a camera. And then you can have your camera's rotations being controlled by an aim constraint, and then the camera moving with the attached to path. Alrighty. So, but here's the orient constraint, and you guessed it, it just takes the orientation of the objects. And so I have this guy on 2, and he's averaging between these two guys. All right, and so, and as you see, he has a average, flip, longest. You know, so you can try different things if you're having problems, and you can also key the weighting between the two so that it takes that into account. Okay, so now he's totally controlled by the blue. All right, so kill him off. Yeah, he's all clean now. Straighten these guys up. Alrighty. Now another handy one. Let's just get this guy back over somewhere nearby. Okay. So skipping down temporarily to the parent constraint. The parent constraint, as you see, order of operations. So I have to remember, select the target object first, the object to move second, and now I hit the parent, and yeah. Okay, and so as you see on the ball, it has the rotations and translate keyed out, and the benefit of the parent constraint is it manipulates the ball as if, as if it is parented. So it has the motion as if it was parented, but it's not actually parented. That is the most powerful, most useful of the constraints, okay? Because it does both, and it mimics that basic parenting, which is fundamental to everything we do. Alrighty. So then we have, let's pull that guy out. We also have the scale. I don't really mess with the scale that much. So I have found a use for it. I was teaching a class with this at some point a few years ago, and you know, I was like, I have never used this, and that very week I found a case where I needed it. So yeah, okay, so there, as I scale these guys, the ball scales, okay, and so it just takes the, you know, it just lines up the scale. So once in a while, that one is oddly enough useful. Okay, so. Alrighty. The other things, oops, I probably should have prepped this, but create NURBS plane. Alright, so I'm just creating a quick NURBS plane here, giving a couple divisions, some patches, and popping over here to surfaces and just building something, some sort of surface here for us to play with. All right, that is definitely a crazy surface. I will take the, oh, I guess I have this green guy. We'll take the green and I'll move his pivot point down to his base, and I'll get the grid out of there for a moment or two so you can sort of see what's going on a bit better. All right. So target object first, which is going to be this ground plane. Grab the green guy, and I'm just going to do a geometry constraint. And so what that does is, as I move this around, it's going to constrain it to the geometry. So if I set a key on this guy, oops, let's go to frame 1, set key, give myself, I don't know, 120 frames, and good, and move him over to here, and set a key on him there. So what happens, as you see, is it hops along a little bit. I don't use this much, okay, so it's having problems getting over like that hump there, but it is trying to constrain itself to that surface as it goes along. So the pivot point is always on that surface. You know, maybe Windows animation editors. All right, so 120. Let's do. Let's toss that keyframe out to 1,000. All right. Well, that is definitely slower. Get it somewhere in the middle. Okay. So now, because I have more keyframes, it's having an easier time calculating that inner stuff in the detail, because it's not trying to do these large hops between checking. So you can see it is actually constrained to my wild surface there, and ghosting, you know, just sort of drifting up and down like a ghost. You're going, all right, yeah, but why why doesn't it go along the surface? And so to do that, we have to do a normal constraint. So I'm selecting the surface again. Let's go somewhere in the middle here. Let's go back there. Okay, so it's on a slope. And you remember the normals. Actually, let's quickly take a quick look at the normals, display, NURBS, and normals. Eesh. All right, so yeah. Those are the surface normals. Looking at the bottom, you can see they are popping off. Let's see, NURBS. All right, so the surface normals come perpendicular to the surface. The yes, let's see, tangent and normal. Blink. There we go. All right, and let's see, z. Okay, so the surface normals are perpendicular to the to the surface, and so what I was hoping to show you just then is how the those hairs stick off of the surface, and by putting this normal constraint, the tip of my cone there is aligning itself for the surface normal on that part of the surface. And so you can sort of see it doing it there as it wanders by. Okay? And so that is, all right, stop. Okay, so that's what the surface normal does. Tangent does it on a curve. I have not played with these guys, they're sort of new. And the pole vector is for a certain, a rotate plane IK solver, so that's a different critter all the way together, all together. But those are your basic constraints and how they work. The key thing is, remember, the target object is selected first. The thing that you want to move to respond to that target object, you select that second, and it locks out